Okay, it's called square trinomials. And the words and the names, they're not that important to me that you know the names of the words, but it really is some a plus b squared. Square trinomial. And the square doesn't come from the fact that it looks like a square at all. That's the square. Now it's called a trinomial because really I'm going to show you why it's a trinomial. Right now it's a binomial, but we're going to make it into a trinomial, okay? So our lesson today is really, again, more FOIL with, I'm going to give you some words, with a square, let's change it to binomial, and we're going to call it difference of squares. These are words that we're going to use more as the weeks progress, okay? This should say square binomial. My bad. Square binomial. Square binomial. Well, example 1 really is a square binomial because it could have been an x plus 2 quantity squared. It could have been. I don't want to write it like that. I mean, this is the form I want it in, but x plus 2 could be x plus 2 squared. Everybody agree with that? But this is just really a different representation. I like this. I like this. So, x times x. X times 2. It's the same process we've been doing, right? We know x times x is always x squared. So x times x is x squared. Grace, will you tell me if I get going too fast? Please. X plus 2 is a positive 2x. And then 2 times x, 2 times 2. 2 times 2 is another 2x, and 2 times 2 is 4. Okay. We can add the two middle terms and make it x squared plus 4x plus 4. That is a great technique. There is a faster way to do it, and I'll talk about it. Okay. How am I doing? Everybody okay with what I just gave you? Everybody good on number 1? Can everybody do number 1? Thumbs up. Let me see. Thumbs up. Everybody good on number 1? Okay. Now number 2, same way. Because of the quantity squared, we're going to write it twice. We're going to write it twice. I will rewrite because the quantity squared, x plus 5 times another, x plus 5, because it really means x plus 5 times x plus 5, quantity squared, right? So I'll do the same process, except for we could probably shortcut it, couldn't we? We could probably shortcut it because I know I'd have a 5x and another 5x, right? I have a 5x, another 5x. I can go straight to a 10x, and 5 times 5 is 25. Now, if you don't want to shortcut it, it's okay. It still works to go x times x times 5. Still works to do it the way I showed you yesterday. X squared plus 5x, and then 5x plus 10. Nope, 25. Just say 10. I meant 25. And then I add my two middle terms, and I get my 10x. Okay. Okay. How am I doing? Doing okay? Now let's take a look at example 3. So a shortcut, and I'll do it, but let's do it the long way first. Let's go x times x and x times a positive 6. It's going to give me an x squared plus 6x, right? And then negative 6 times x and negative 6 times a positive 6 is going to give me a negative 6x and a negative 36. So the middle two terms cancel. They cancel. 6x, negative 6x. And then you're just left with an x squared minus 36. Now again, some of these you can see. When I look at this, I know I'm going to have a positive 6x and a negative 6x. I see the difference. See the difference? Negative 6, positive 6. And in this case, I knew that the 6x's would cancel, right? I don't know or care if you like my shortcuts. You don't have to do the shortcuts. You do not. You can just do it the way we are doing it, what I showed you yesterday, okay? How am I doing? Not too fast? Am I pacing okay? All right, you guys ready to turn the page? All right, let's turn the page. All right, now, let's do example 4. Well, 2x times 2x, 2x times negative 5, which should be a 4x squared minus 10x. And then 5x times 2 and 5 times 5 gives me a positive 10x and a negative 25. Again, the middle two terms cancel, don't they? Negative 10x, positive 10x, middle two terms cancel, boom, boom, gone. And I'm just left with a 4x squared minus 25. So if you look at the original question, can you see that? Can you see it? I mean, I don't care if you shortcut it, but some kids can. Can you see the negative 10x, positive 10x? You can see how they would cancel, can't you? How about example 5? Can you see the shortcut? I'm going to get a negative 12x squared, a positive 12x squared, right? So if I shortcut this, and I'm going to do it both ways. If I shortcut this, 9x to the 4th minus 16 will be my answer. Can anybody see how I got that? I'm going to do it the long way because it doesn't hurt to do it the long way, the way I showed you yesterday. 3x squared times 3x squared and 3x squared minus 4. Now, x squared times x squared times is x to the 4th, okay? So, 3x squared times 3x squared is a 9x to the 4th. 3x squared times a negative 4 is a negative 12x squared. Okay, I'll do the inside. 4 times 3x squared and 4 times a negative 4. 4 times 3x squared is a positive 12x squared. And 4 times a negative 4 is a negative 16. Okay, again, what I see is two middle terms cancel, right? And I go straight to that answer there. What do you think? Okay, last but not least, x cubed times x cubed. What's x cubed times x cubed? What's x cubed times x cubed? Anybody?
X to the 6.
Good, it is. So this is going to be an x cubed plus 3 times another x cubed plus 3, right? So let's go ahead and do it. X cubed times x cubed is x to the 6th. X cubed times 3 is a positive 3x cubed. 3 times x cubed is a positive 3x cubed again. And then 3 times 3 is 9, right? These two don't cancel, but I'm going to combine them. I'm going to put these two terms together. 3x cubed plus 3x cubed is a 6x cubed because you're adding. This is a positive 6x cubed because you're adding. And there is my answer. Avi, you want to show the guys the homework? Okay. So homework for today. Page 46, 47.
Good idea.
Okay. Yep, page 46, 47. Yeah, it's easy. It seems like a lot, but these are pretty easy. 1 through 18, all. Okay, start the recording. We have lots of time to get this done. Lots and lots and lots and lots.